Let's look at using Spark and BigDL libraries on Kuberlab to train a new model. First, we'll log in, choose a workspace, and create a new project. From the list of frameworks, we'll choose the BigDL Spark project. We'll select the cluster where we want to install this project, configure some details like the application name, select a storage configuration, specify the GitHub repository with our model code, the dataset images for training the model, and the cluster Spark mode from the selection list here. Once we confirm these settings and install, we can see the summary page. From the summary page, you can jump over to the Jupyter tab to view or edit your code and explore data. Or you can head over to the Spark tab and see the status of your cluster. Now let's launch the training of the MNIST model. Here is the source code for our model. Since we're using the default configuration, we must first configure the tasks, starting with launching the construction of the model. The job, which is the Spark driver, will facilitate the Spark connection and execute our script. We'll name it BigDL MNIST train. We'll leave the default settings for the rest of this, since it doesn't require much in the way of resources. Next, we'll configure our workers. These will be created when the task is started. 2 should be enough for this task. We'll save and execute this, and we'll leave ourselves a little comment for later. Now we can monitor the progress of the task in real time. Spark workers are created, and the driver is launched. Over here in the Spark UI, we can see the result details. If we head over to the Metrics tab, we can see our resource usage. This will include details about the RAM, CPU, and GPUs if they are used. Here you can see the logs are easily accessible for detailed review and troubleshooting. Here you can see our model is ready. You can see the predicted test accuracy, and the runtime duration is about 6 minutes. Now we'll create a new ETL process to utilize that model. We'll create a new Spark job in the task panel by copying this existing one. Now here is their source code. It will read the images from our dataset, distribute them among the workers of our cluster, and make a prediction of the number of each image, as well as a summary of all predictions made during the run. Now we'll configure the Spark driver and workers. We set the executable script with parameters which include the dataset and model checkpoint location, and launch the inference task. This is a pretty quick task since we don't have to train the model. Spark workers are dynamically launched and utilized, and the RDD can be saved for use with future processes. Here you can see we've submitted our application and the workers are busy. Back here in the Spark tab, we can see that our workers are stopped and the job is finished. The Kuberlab platform enables your lifecycle management by making versioning easy. Kuberlab supports full versioning of all tasks and components used in the project. You can check out the previous task, the whole project, or anything in between to create a new branch or experiment. We'll capture the source code version, the dataset version, environment, hyperparameter version, everything, so at any moment we can precisely recreate a previous run. Here you can see some of the other features Kuberlab offers. Catalogs of model source code, pre-trained models, examples, datasets, even a built-in hyperparameter optimization engine.